Okay, so today we're doing trig identities, verifying them, but we're taking it to kind of the next level. Okay, we're going to do some that are a little bit more difficult. The last couple of days we've been using really easy basic ones, but today we're going to start making it a little bit more complicated. Okay, so let's look at the first one. We have to prove that secant minus cosine divided by tangent is equal to sine. Okay, so we're verifying this. It's already a true statement. Okay, this is already been proven that these two things are equivalent. Now we got to show you basically how do we get from the left side to the right side. Okay, and there's going to be more than one answer. Okay, so if I work it basically how my students would work it, and the first thing that they would probably do is change tangent to sine over cosine. Okay, so secant x minus cosine x over sine x over cosine x. Okay. Then at this point, you could actually multiply by the reciprocal. So you get secant x minus cosine x times the reciprocal of the bottom, which would be cosine x over sine x. Okay, and then multiply, which would multiply this, and you distribute that in, and then you get secant x cosine x minus cosine squared x all over sine x, because when you multiply fractions, you multiply numerator times numerator and denominator times denominator. And then secant times cosine, they're reciprocals. So when you multiply reciprocals, you end up with 1. So you end up with 1 minus cosine squared over sine. And then 1 minus cosine squared, that's the Pythagorean identity, which is sine squared x over sine. And sine squared is sine times sine divided by sine, which is just sine x. And that gets you to where we originally started. Okay, so here are all the steps going through it. Okay, now another way of doing it is you could have, instead of doing this first, you could have changed tangent. Dividing by tangent is the same thing as multiplying by cotangent, and you would have gotten basically to this step here doing that way. Another way of doing it, which would make it so much easier, is if you knew, and this would be the second way I would suggest, is tangent. If you have a formula chart, tangent is sine x times secant x, because sine over cosine is the same thing as sine divided by cosine is the same thing as multiplying by its reciprocal of cosine, which is secant. So you could have changed that to this, secant x minus cosine x over sine x times secant x. Okay. Now, since these two things are being multiplied, you could have just multiplied by the reciprocal of secant, so that would have been cosine x times secant x minus cosine x over sine x, which would have saved you a couple of steps, because you basically would be at this point now. Okay, you multiply the cosine in, and you could do it that way. Or you also could have done it this way, and instead of changing this and bringing it up and multiplying it by cosine, another way of doing it would have been actually doing it this way and separating it. So you would have had secant x over sine x secant x minus cosine x over sine x secant x, like that. And then this would have divided out with that, and then you would have ended up moving that up there, and you basically get the same place. Okay, but I'm going to do it a way that a lot of my students wouldn't think about doing it, and I'm going to force factor. Okay, so for instance, if I was here with sine times secant, and I see secant in the numerator, I could force factor the numerator by factoring out a secant from both terms. And when I force factor this, secant divided by secant is 1, minus cosine divided by secant, which is cosine squared, over sine times secant x. And so you go to here, changing sine divided by secant, and then secant divides out with secant, which basically gets you all the way down to this step right here. And then you basically have 1 minus cosine squared x over sine, and that's sine squared x over sine of x, which is just sine x. Like that. So here are 3 different ways of doing this problem, okay? Each one unique in a way, or playing off of each other. So again, it depends on how you see the problem, okay?